In lesson 15.7, we're going to look at an application of expected value related to strategy in sports. Expected value can be a tool that coaches and other athletes help use to determine their best strategy in different sports scenarios. For the first example, we're going to look at the situation where a team in football scores a touchdown. And with every touchdown, they get 6 points, but they also get to try for either an extra 1 or 2 points. The ball is placed on the 3 yard line. They get 1 point for a kick through the goalpost, or they get 2 points for any other play that moves the ball across the goal line. This is what we usually refer to as a 2 point conversion. Most teams would have a 95% probability of success rate for a kick to get the extra 1 point, but only maybe a 50% probability of success to gain the 2 yards or the 3 yards needed to score the 2 points. So there's some potential risk and reward in this situation. If you go for the riskier situation, you can potentially earn more points. However, there's also a greater chance that you'll end up with no points at the end, because if the 2 point conversion doesn't work, you get 0 extra points. So we would want to know in this case, what's the best strategy in the long run for a coach to use? What we're going to do is set up 2 tables to calculate the expected value of our random variable. And the first situation is that the coach chooses to go for 1 point. In this case, the number of points that the team could get is either going to be 0 or 1. 1 meaning that the extra kick was successful, 0 meaning that they missed the extra kick. We're told in the problem that the chance of them being successful when they kick the ball for 1 extra point is 95% or 0.95. Therefore, the probability that they are unsuccessful and get 0 points would be 5% or 0.05. Now, in the situation where the team decides to try for the 2 point conversion, they're either going to get 0 or 2 points. So those are the possible values for X. We know that the team is only successful 50% of the time. That means the other 50% of the time, they're going to score 0 points on that 2 point conversion. Now, what we're going to do is calculate the expected value of X for each of those cases. So for the top case, where they go for 1 point, the expected value would be 0 times 0.5 plus 1 times 0.95, which gives us an expected or a long run average of 0.95. That means in the long run, the team can expect to score 0.95 points on average when they go for the field goal. Now, for case number 2, where they go for the 2 point conversion, the expected value would be 0 times 0.5 plus 2 times 0.5, which gives us an expected value of 1.00. That means in the long run, they're going to actually get a little bit more points per try if they go for the 2 point conversion than kicking for 1 extra point. So in the long run, the better strategy would be to go for 2. So we'd say in the long run, if a football team attempted extra points many times, their best strategy would be to go for 2. Let's look at another example. In the 2016-17 season, the Spurs finished near the top of the NBA for 2-point and 3-point shooting percentages. A sports analyst suggests that it's a better strategy for them to shoot more 3-point shots, which are worth more but are less likely to be successful, instead of 2-point shots, which they're more likely to make but are worth fewer points. And we're going to calculate the expected value in each of these cases to verify that this analyst is in fact correct. So we're going to set up our table similar to what we did in example number 1. If they attempt a 2-point shot, they're either going to make it or miss it. If they make it, they're going to get 2 points. If they miss it, they'll get 0. And in the problem, it says that for 2-point shots, the probability of being successful is 0.469. We can subtract that from 1 then to find the probability that they miss the shot, which would be 0.531. Now, for a 3-point shot, they're either going to make it or miss it, meaning if they make it, they get 3, and if they miss it, they'll get 0 points. Their probability of being successful here is only 0.391. And if we subtract that from 1, that tells us that their probability of being unsuccessful is 0.609. Just like we did in the first example, we'll calculate the expected value of each of these 2 scenarios. So for the 2-point shot, the expected value is 0.938. For the 3-point shot, their expected value is 1.173. So the sports analyst is in fact correct that in the long run, it's a better strategy for them to go for more 3-point shots. Now, the second question or second part to this question is, what would their 2-point percentage have to be so that is actually a better strategy to attempt more 2-point than 3-point shots? We saw in the first part that with these given probabilities, it's a better strategy to go for 3. So, what we know is that in order for the 2 point shot to be a better strategy, this probability would have to go up. The question is, what would it have to go up to? And we're going to calculate that using some algebra. So I'm going to fill in my chart sort of in a similar way that I did in the first part, where for a 2 point shot, they can either get 0 or 2 points. And for a 3 point shot, they can either get 0 or 3 points. Now we're going to assume that their 3 point probabilities stay the same. Therefore, their expected value would be the same as well. For a 2 point shot, though, we want to change those probabilities. So now we want to say, what would the probability of success have to be for this 2 point shot? And since we don't know that, I'm going to call that P for probability. Now, if the probability that they're successful is P, the probability that they are unsuccessful would be 1 minus P. And I can calculate their expected value using the formula and those variables. So if I did for the expected value for this top chart, 0 times 1 minus P plus 2 times P, that would simplify to be just 2 times P, since 0 times 1 minus P is simply 0. So the expected value for their 2 point shot now is 2P. Their expected value for their 3 point shots is still 1.173. And our question is, when is a 2 point shot better than a 3 point shot? In other words, when is the expected value for a 2 point shot greater than 1.173? So we get a very simple algebra equation that we can solve simply by dividing both sides by 2. And when I do that, I get P is greater than 0.5865. That tells us that if their 2 point percent success rate is greater than 58.65%, it would be better for them to shoot for 2 points instead of 3 points. Please do the 15.7 homework in your assignment packet.